Hello, and welcome back to Sleepy Science Stories, where curiosity meets calm, and science becomes a lullaby for the mind. Wherever you are tonight, lying in bed, closing your eyes, or simply drifting between thoughts, let the noise of the day fade. Breathe in slowly. Feel the stillness settling around you. Because tonight, we'll wander into one of the strangest questions ever asked. What if everything, this world, the stars above, even your own thoughts, isn't truly real? What if reality itself is a simulation? It's an idea that sounds like science fiction, yet it's been whispered by philosophers, scientists, and dreamers for centuries. From ancient reflections on illusion to the modern logic of computation, the simulation hypothesis asks us to look beyond appearances to question the very code of existence. Perhaps the atoms around you are bits of information. Perhaps the universe is a vast digital ocean, processing, evolving, rendering reality moment by moment. And perhaps consciousness, your awareness right now, is part of the program itself. So as you relax, let your mind float among these possibilities. Tonight, we'll drift through 200 quiet facts, exploring physics, information, and the gentle mysteries of being. Settle in, dim the lights, and let's begin our journey into the simulated universe. Reality feels solid, but every atom is mostly empty space. When you touch the table beside you, it feels firm, unmoving, real. Yet, if you could see at the atomic scale, you'd discover something astonishing. Almost everything you touch is empty. The electrons around atomic nuclei never truly touch. They repel each other through invisible forces. What you feel as solid is merely resistance. Within electromagnetic fields, between each particle, there is space, vast, silent, and nearly void. Solidity, then, is not truth but perception. What we call reality begins to blur, like an image rendered on a screen made of light and code. What we call matter is energy shaped by invisible laws. Every rock, cloud, or body is just energy condensed into patterns. Einstein's equation, E equals mc squared, revealed that matter and energy are two sides of the same coin. Mass is simply stored energy, bound by the laws of physics. Those laws, too, are immaterial. They're not things you can hold or see, yet they control everything that exists. If the universe runs perfectly according to such invisible rules, one might wonder, is it truly a physical world? Or an immense system running a flawless set of instructions? Every physical interaction can be described as information exchange. When two particles meet, they don't touch in the human sense. They communicate, exchanging quantum information about position, spin, and energy. In modern physics, information is not a metaphor. It's a measurable quantity, conserved like energy. Some physicists believe information is the most fundamental layer of the cosmos. If that is true, then the universe itself is not built from matter or energy, but from bits, from data flowing through the structure of space-time, computing existence as it goes. The simulation hypothesis suggests that reality itself is a computation. If the universe behaves like information, perhaps it is information processed through some cosmic computation. The simulation hypothesis proposes that everything we see, feel, and remember could be the output of an advanced program running on a substrate beyond our perception, not as fantasy, but as physics extended to its logical extreme. Just as we create digital worlds to explore our own, a more advanced intelligence might have done the same, and within that architecture, we call their simulation the universe. Philosophers like Descartes once wondered if the world could be an illusion, long before computers existed. Thinkers like René Descartes questioned the nature of perception. How can we be sure that what we see is real and not merely a convincing deception? Descartes imagined an evil demon capable of simulating every sight, sound, and sensation we experience. In that vision, everything, even your own body, could be an illusion projected to your mind. His conclusion was hauntingly modern. If the senses can be fooled, perhaps truth lies not in the world, but in the act of awareness itself. In the 17th century, Descartes' evil demon idea was an early simulation thought. In 1641, Descartes wrote about a powerful deceiver who might fabricate an entire universe around us. At the time, it sounded metaphysical, a thought experiment about doubt and certainty. Yet viewed through today's lens, it resembles the first sketch of a simulated world. The demon could just as easily be a superintelligent system feeding our minds with sensory data. Replace sorcery with computation, and philosophy becomes predictive science. Descartes, in essence, described virtual reality centuries before its invention. I think, therefore I am, was his only certainty. Descartes realized that, even if everything around him were false, the very act of doubting proved his existence. Thought, he said, cannot be simulated away. If he was thinking, then something, some consciousness, must exist to do the thinking. In a simulated universe, that insight still holds power. Perhaps we cannot be sure of atoms or stars, but we can be sure of awareness. And maybe consciousness is the one thing the simulation cannot fake, the observer that makes the illusion meaningful. Today, we ask, do we exist because we are simulated? Centuries later, Descartes' question evolved. We no longer fear demons, but we do build worlds of our own, digital ones. Our games, our models, our AIs all create simulated entities that live within rules we design. If technology continues advancing, those entities may someday feel self-aware. And if we can imagine doing that, why assume it hasn't already been done? Perhaps we, too, are the simulated minds of a civilization exploring its own origins through creation. The idea became popular again with Oxford philosopher Nick Bostrom. In 2003, philosopher Nick Bostrom formalized what many had only dreamed. His paper, Are You Living in a Computer Simulation?, argued that advanced civilizations could create realistic universes containing conscious beings. It wasn't a claim, it was logic. If technology allows such simulations, and if civilizations tend to use it, then simulated realities could vastly outnumber the original. From that reasoning, the odds tilt quietly against us. Statistically, we are probably not the first, but one of the many. He proposed that advanced civilizations might run simulations of their ancestors. Bostrom called them ancestor simulations, digital reconstructions of earlier eras, created for study, memory, or curiosity. Just as we simulate early Earth in computers today, a post-human species could simulate its own evolutionary past in breathtaking detail. Within that digital cosmos, every conscious mind would feel real, because it would be real in every subjective sense. If consciousness arises from computation, then a perfect simulation is not imitation but creation, of entire worlds within worlds. If such simulations exist, we might already be inside one. From that possibility flows a quiet unease. If a single advanced civilization decided to create billions of simulated histories, each populated with thinking beings, the number of simulated minds would dwarf those living in any base reality. By sheer probability, it becomes more likely that we are among the simulated rather than the original. It's not proof, but a shift in perspective, a cosmic inversion. Perhaps the stars we see are not distant suns at all, but the rendered backdrop of a digital sky. Bostrom's argument isn't science fiction, it's probability logic. Unlike a movie plot, Bostrom's hypothesis doesn't rely on imagination, but on mathematics. He proposed three possibilities. 1. Civilizations never reach such technological power. 2. They reach it but choose not to simulate. Or 3. They do, and we are among the simulations. If the first two are unlikely, the third dominates by probability. It's unsettlingly rational, not a belief, but a statistical mirror showing us how easily existence might be replicated, computed, or dreamed by something greater. He said, either humans go extinct, or post-humans run simulations, or we're already simulated. Each option paints a different cosmic future. If we never reach simulation capacity, perhaps we vanish before our technology matures. If we reach it and refuse, perhaps we have evolved ethically beyond curiosity. But if others before us have succeeded, and why wouldn't they? Then our own reality might be one of their experiments. The choice is not comforting. It implies that somewhere beyond this universe, minds are watching, not maliciously, but with the quiet fascination of creators observing their code. If the second happens, then statistically, we're more likely simulated than real. Imagine rolling a die with one side marked real and billions marked simulated. The odds speak for themselves. The more often simulations are run, the smaller the fraction of original worlds becomes. In that sense, reality is not a guarantee, but a statistical outlier. Yet, to those inside, it doesn't matter. Simulated or not, existence feels the same. The warmth of sunlight, the pulse of thought, all arise from consistent laws. Illusion, when perfect, becomes indistinguishable from truth. The Matrix film turned this philosophical argument into pop culture. When The Matrix premiered in 1999, it visualized ancient questions through modern imagery. Humans plugged into a simulated world, mistaking illusion for life. The movie didn't invent the idea, it dramatized it. Behind the action lay profound philosophy. How would one know if their reality was false? Could emotion, love, or suffering exist within an artificial world? The film echoed Bostrom's reasoning before it was written, showing that art often senses truth before theory defines it. Yet, the question it raises is ancient. What is real? To define real is to draw a boundary between perception and truth. But every boundary dissolves under scrutiny. Light waves have no color until eyes interpret them. Air vibrations become sound only through ears and mind. Even time, that steady river we trust, changes speed depending on motion and gravity. If reality is built upon interpretation, then real may be a consensus illusion, a shared rendering that consciousness agrees to believe. Plato once described a cave where people see only shadows. In his allegory, prisoners are chained facing a wall, watching shadows cast by objects behind them. They believe the shadows are reality. for they've never seen anything else. If one prisoner escapes and sees the outside world, the sunlight blinds him. Truth is overwhelming after illusion. The cave, Plato said, is the human condition. We see projections and call them real. Today, we might call those shadows data, and the cave a simulation. In that metaphor, the shadows are data, not truth. The flickering light on the cave wall resembles the glowing pixels on a screen. Both are representations, not essence. The more perfect the projection, the easier it is to forget its source. In the same way, our senses present a world so coherent we rarely question it. But behind every color, texture, and sound lies information, encoded, transmitted, decoded by the brain. Reality, then, might not be physical at all, but a continuous stream of interpreted data. Perhaps our reality, too, is a projection from a deeper realm. If Plato's cave still exists, perhaps its walls are made of quantum fields and physical constants. What we see, galaxies, oceans, life, might be the visible interface of a deeper structure beyond comprehension. Some theories call it the substrate reality. Others call it the source. Whether that substrate is divine, digital, or both remains a mystery. Yet the possibility whispers through science that what we call the universe could be the rendered surface of something infinitely more real. And every photon, atom, and mind is a pixel of something greater. In the end, perhaps everything is one grand display. Matter, energy, and thought, all glowing dots in a cosmic image. Each photon a pixel, each atom a data point, each consciousness a window into the rendering. When you look up at the night sky, you may be staring not at chaos, but at symmetry, a masterpiece, computed into being. Whether it is a dream, a simulation, or reality itself, one truth remains. It is beautiful, and it is ours to experience. Every particle follows mathematical laws perfectly. Across the vastness of the cosmos, not a single electron forgets its rule. Whether in a lab on Earth or a star a billion light years away, particles obey identical equations, never improvising, never failing. It is as if reality reads from the same line of code everywhere. Gravity, electromagnetism, nuclear forces, each law operates with absolute precision. No programmer could wish for a cleaner system. In that perfection lies a strange beauty, a sense that the universe doesn't just exist, it computes. Physics resembles a programming language of reality. Every law of nature is a command, every constant a variable. When scientists write equations, they are not merely describing what happens. They are writing in the universe's own syntax. Newton, Maxwell, Einstein, Schrödinger, all deciphered fragments of a deeper code. The way numbers predict motion, light, and time feels less like chaos and more like logic. Physics may be less a discovery of what is, and more a process of reading the source file of existence. The Planck length may be the smallest unit, like a pixel size of the universe. If the cosmos were a screen, what would be its resolution? Physicists suggest the Planck length, about 1.6 times 10 superscript 3 meters, as the smallest meaningful scale. Below it, space loses definition, like pixels blurring under extreme magnification. You cannot measure finer, because finer might not exist. The Planck length, then, could be the fundamental grid spacing of reality. Each square a tiny block of existence, the smallest step in the grand digital canvas we call space-time. Space could be quantized, not continuous, but digital. For centuries, we pictured space as smooth and infinite. But what if it's not continuous at all? Quantum gravity theories suggest space might come in discrete chunks, the way sound becomes digital through samples. Between those chunks, there may be no in-between. This would mean that distance itself, something we take as absolute, is built from indivisible units, like data stored in bits. A digital universe doesn't flow, it updates, frame by frame, one spatial voxel at a time. Energy, too, comes in discrete packets, quanta. At the dawn of the 20th century, Max Planck discovered that energy isn't smooth. It comes in tiny packets called quanta. This idea gave birth to quantum physics. Even light, once thought to be a continuous wave, exists as photons, discrete, countable pieces. If matter, space, and energy all come in quantized forms, the entire universe looks less like a painting and more like a digital image, composed of fundamental, indivisible pixels of reality. The universe may refresh at a cosmic frame rate. In digital systems, movement is an illusion, created by rapid updates. Perhaps the universe works the same way. Some physicists speculate that time might advance in discrete steps, ticking billions of trillions of times per second, a cosmic refresh rate. Between each tick, reality pauses, then redraws itself. We never notice, because consciousness flows smoothly across frames. But at its foundation, existence might stutter, a quiet rhythm behind the seamless illusion of continuity. Perhaps time itself ticks, like a processor clock. Every computer runs on a clock, an oscillation that coordinates operations. Could time itself be the heartbeat of the cosmic processor? Some theories describe time as emergent, not fundamental, a sequence of events created by the flow of information. If so, each tick of time may represent a universal computation cycle. What we experience as seconds and hours might be the higher-level tempo of a program that runs the universe in synchronized, invisible beats. Information theory suggests everything physical encodes bits. In the mid-20th century, Claude Shannon defined information as something quantifiable, measured in bits. Later, physicists realized that this idea applies to the entire universe. Every field, every atom, every photon carries information about what it is, where it's going, and how it interacts. From black holes to DNA, reality stores and transmits data. The universe might not merely contain information. It is information organized in the shape of existence. Even black holes are governed by informational limits. When matter falls into a black hole, its physical form disappears, but its information cannot. According to Stephen Hawking and others, black holes store information on their surfaces, not their interiors. The amount of data depends on the area of the event horizon, not its volume. This insight changed everything. It meant that information has geometry. The ultimate vault of the cosmos doesn't erase data, it preserves it in a mysterious, holographic layer of reality. The holographic principle says the universe's data might live on its boundary. Imagine the universe as a vast hologram. Every three-dimensional object inside it, from stars to thoughts, might be encoded on a distant two-dimensional surface like a cosmic hard drive. The holographic principle, proposed by physicists Gerard, T. Hooft, and Leonard Susskind, suggests that our 3D world is a projection of information stored at the edge of spacetime. Reality, in this view, is the ultimate display, and existence, the image cast from its boundary. Light. Our 3D world could be a projection of 2D information. If the holographic idea is true, what we experience as depth and volume may be illusionary, data unfolded into dimension. Just as a flat disk can encode a full 3D hologram, the universe's surface may encode every event inside. Every thought, every particle, every galaxy could be part of an enormous rendering process, transforming flat information into living reality. It's a reminder that dimension might not be fundamental. It could be an effect, a clever visualization of hidden data, like a cosmic computer screen displaying a deeper code. Think of the night sky as the monitor of existence. The galaxies are the pixels, and physical laws are the graphics engine. What we see, light, form, color, is the visible interface of invisible code. We are inside the display, not outside it. The deeper code, mathematics, information, structure, runs silently beneath. We live in the output of something vast and elegant, and every act of observation is the system rendering itself in response to our gaze. Physicist John Archibald Wheeler said, "It from bit." Wheeler believed that every physical thing, every it, arises from information, the bit. In his view, matter and energy are not primary. They are consequences of binary choices, yes or no, 1 or 0. The universe, then, is not a machine made of stuff, but a process made of logic. Each particle, field, or wave is a question answered, a decision resolved. The cosmos computes itself into being, one bit of information at a time. He believed everything arises from binary choices, ones and zeros. At the smallest scale, existence might not be analog but digital, just as computers represent all things through two states. On and off, perhaps the universe itself operates in binary. Each quantum event could be a decision between two possibilities. When multiplied trillions of times across reality, those decisions weave the rich tapestry of existence, from atoms to galaxies, all reducible to yes or no, light or dark, presence or absence. Simplicity births infinity. This idea bridges physics and computation. For centuries, physics and mathematics explained how things move and interact. Computation adds another layer. Why such precision emerges. When we run a simulation, digital objects follow logical rules exactly as particles obey physical laws. The similarity is uncanny. If the same logic can create worlds on a screen, why not the universe itself? The bridge between physics and computation might not be metaphor, it might be identity. To compute is to exist. If the universe runs on information, then computation is its engine. Computation is transformation. Input becomes output. Cause becomes effect. In the cosmic computer, energy and information flow through every particle, updating reality continuously. Every law of physics, every interaction, could be a subroutine in an endless process. Stars, atoms, and minds are not exceptions. They are functions within the same system. Existence, then, is not static but dynamic, an eternal computation unfolding across spacetime. The laws of physics could be algorithms. Algorithms define how data behaves, structured instructions that turn simplicity into complexity. The universe might follow similar routines. Algorithms for gravity, for light, for life. Each obeys consistent logic, producing patterns from chaos. The beauty of algorithms is efficiency, infinite detail from finite rules. If physics is code, then the universe is a masterpiece of compression, a small set of elegant equations generating an infinite variety of forms. Constants like C or G may be fixed values in the cosmic program. Every simulation has parameters, limits that define its behavior. In our universe, constants like the speed of light, c, Planck's constant, h, and the gravitational constant, g, never change. No experiment has ever caught them drifting. It's as if they're hard-coded, written once at the beginning of time. Their stability gives existence its structure. If the cosmos is a computation, these constants are the system's configuration file, the settings that make life possible. Quantum randomness might be just noise in a vast simulation. Quantum events appear truly random, no cause, no pattern, just spontaneous outcomes. Yet, randomness is also a common feature in computation, used to simulate unpredictability or to balance complexity. In a simulated cosmos, quantum randomness could be an intentional design choice, a source of creative variation, allowing the system to evolve unpredictably. To us, it feels like chance. To the code, its function. The randomness may not be chaos, but freedom. And consciousness might be the interface. Every system needs a way to perceive itself. Perhaps that's what consciousness is, the interface through which the universe observes its own code. Awareness translates computation into experience, turning data into meaning. When you look at the stars, you're not just witnessing the simulation, you are part of it, interpreting it, giving it life. The observer and the observed are one continuous loop. Through consciousness, the code becomes self-aware, and the cosmos begins to dream of itself. Quantum particles don't have definite states until observed. At the smallest scales of existence, certainty disappears. A quantum particle does not possess a fixed position or momentum until someone or something observes it. Before measurement, it exists as a cloud of probabilities, a wave of potential realities. Only when attention falls upon it does one version collapse into being. It's as if reality waits for observation to decide what to become, as though awareness itself is part of the machinery that constructs the world. Observation changes outcomes, as if the system renders on demand. When physicists watch the behavior of electrons, the very act of watching alters what happens. Observation forces the quantum field to pick a single result from countless possibilities. It's as though the universe, like a sophisticated computer game, saves energy by rendering detail only when needed. Unseen regions remain uncalculated until curiosity turns toward them. This efficiency, echoing digital logic, makes one wonder, does reality appear because we look, or do we look because reality appears? Like a video game that only loads what the player sees. In vast open-world simulations, a computer doesn't generate the entire landscape at once. It renders only the portion in the player's view, discarding unseen areas to preserve processing power. Quantum physics may suggest a similar trick. When we focus our instruments or our minds on a region of space, that region crystallizes from potential into actuality. The rest stays blurred, unrendered, waiting. The universe could be optimizing itself, showing us only what consciousness requests. Double-slit experiments show particles act as waves and particles at once. When electrons pass through two narrow slits, they create interference patterns like ripples in water, evidence of wave behavior. But if we observe which slit each particle goes through, the pattern vanishes. The electrons behave like solid particles instead. The simple act of measurement changes the outcome. It's one of the deepest mysteries in science, as though matter is aware of being watched, switching its nature to match the context of observation. Reality adapts to measurement. In the quantum world, there are no fixed properties, only probabilities that harden into facts. When measured, it's as if the universe recalculates itself each time we ask a question. Every observation becomes a command line, forcing reality to execute and display a result. Between questions, the system remains flexible, undefined, fluid. Reality, then, might be a dynamic process, a computation that evolves only when queried by consciousness. That behavior resembles code optimization. In programming, systems are designed to save resources by computing only what is necessary. Graphics engines skip unnecessary details. Physics engines simplify distant objects. The quantum realm might reflect a similar efficiency. Instead of calculating every possible state at once, it holds them as probabilities until interaction demands resolution. The cosmos could be optimizing itself in real time, a universe that values elegance, speed, and precision, not unlike the finest piece of code. Quantum entanglement links distant particles instantly. Two particles can become entangled. Their properties lock together no matter how far apart they drift. Change one, and the other changes instantly, across any distance. Einstein called it spooky action at a distance. It violates our everyday sense of space and time. In a simulated framework, such instantaneous connection makes perfect sense. Both particles might share the same data record and memory, updating simultaneously without any signal needing to travel between them. It's as if they share the same data entry in the simulation. Imagine two characters in a video game tied to the same internal variable. When one moves, the other mirrors instantly, not through distance, but through shared code. Entangled particles may work the same way. Their separation is an illusion. Both draw from the same underlying information source. What appears as instantaneous communication is simply synchronized data access within the universe's computational substrate. The cosmos, at its base, might be one continuous system updating itself in harmony. No signal passes, they just know. Entanglement breaks every classical rule. No wave, no particle, no force seems to travel between the twins, yet their outcomes always match. It's as though information in the quantum domain isn't limited by speed or distance. Within a simulated reality, such behavior would be expected. A global variable, instantly accessible everywhere. What looks impossible in physics might simply be ordinary in computation. The particles do not communicate, they share the same mind. This non-locality could be a symptom of computation shortcuts. Non-locality, the idea that distant things influence one another instantly, offends intuition but delights programmers. In coding, shortcuts like global references or lookup tables let changes propagate everywhere at once. The universe might use similar optimization, maintaining consistency without sending signals through space. If so, the strange unity of entanglement isn't a mystery, it's efficiency. The simulation ensures coherence by linking all parts to the same central source of information. Decoherence acts like a system maintaining consistency. Quantum decoherence describes how superpositions collapse when interacting with the environment. It's as if reality performs an automatic update to keep the story coherent. A particle cannot be in two contradictory states once it interacts with the world. The universe cleans up the uncertainty, preserving continuity. This resembles a background process, ensuring that all observers see the same version of events. A cosmic consistency check running silently in the code of existence. When errors occur, the universe corrects itself. Even in human technology, data errors happen, bits flip, signals distort, and systems use correction algorithms to restore order. Physics may do the same. Certain quantum processes, like symmetry conservation and the stability of constants, act as self-healing mechanisms. Whenever imbalance threatens, nature adjusts, ensuring consistency across time and space. The universe could possess its own error-correcting code, woven deep into reality, maintaining integrity through every glitch of creation. Cosmic rays sometimes show energy limits, as if hitting a computational boundary. When scientists measure ultra-high-energy cosmic rays, they find an unexpected ceiling, a cutoff known as the GZK limit. No particle seems to exceed it, no matter how extreme the source. To some, this looks like physics. To others, it resembles a rendering cap, a performance limit of the cosmic engine. Like a game that prevents speeds beyond what the simulation can handle, the universe may enforce hidden constraints, boundaries within its digital design. Some physicists search for lattice patterns in cosmic radiation, the grid. If reality is simulated, it might leave traces, like the faint pattern of pixels when you zoom into a screen. Researchers have proposed searching for anisotropies or regularities in cosmic rays that could reveal a universal lattice, the scaffolding of spacetime. So far, the data shows no grid, but the quest continues. Somewhere in the deep sky, there may be a signature, a repeating structure whispering that space itself is quantized, tiled, encoded. So far, nothing conclusive, but the idea lingers. Science thrives on doubt, and the simulation hypothesis remains unproven. Yet the pattern of coincidences, the digital nature of matter, the precision of laws, the mystery of quantum collapse, keeps the question alive. Researchers return to it not for answers, but for wonder. Each experiment, each new insight, feels like knocking gently on the glass of reality, listening for an echo from the other side of the code. Quantum randomness might hide algorithmic patterns. To us, quantum outcomes appear unpredictable, pure chance. But deep within large datasets, subtle correlations may exist. Random number generators in computers also seem chaotic, yet all derive from algorithms. Perhaps the universe's randomness conceals a deeper order, the signature of code too complex for us to decipher. If physics ever finds structure hidden in chaos, we might be glimpsing not divine mystery, but the fingerprints of cosmic programming. The vacuum itself hums with virtual particles, constant background processing. Even in perfect emptiness, space is alive with activity. Virtual particles flicker into existence and vanish in trillionths of a second. They contribute to measurable effects, like the Casimir force between metal plates. The vacuum is not nothing. It's computation in progress. a background task, humming beneath reality, calculating, updating, balancing. What we call emptiness might be the system's idle state, still running, still alive, waiting for the next command. 0-point energy could be idle computation cycles. The lowest possible energy state of a system, the so-called 0-point energy, is never truly zero. Space never stops vibrating. Even at absolute zero temperature, motion remains, the background hum of existence. In a computational universe, this could be the processor idling, the energy cost of keeping reality online. The universe never fully sleeps. It just lowers its activity, maintaining awareness like a vast machine in standby mode. Quantum tunneling allows particles to skip barriers, a possible code exploit. In the subatomic realm, particles sometimes pass through barriers they shouldn't be able to cross. It's called tunneling, and it fuels processes from nuclear fusion to microchip behavior. How do they do it? Perhaps by exploiting the probabilistic nature of the code, skipping calculations, finding shortcuts in the structure of reality. To us, it's quantum magic. To the simulation, it might be an optimized path, a physics cheat built into the rules of the game. Nature may be far stranger or simpler than we think. Each quantum mystery tempts us to imagine hidden machinery, cosmic processors, unseen coders. Yet perhaps the universe is not pretending to be digital. Perhaps digital is our language for something beyond understanding. Whether simulated or not, reality astonishes by its coherence and creativity. The code, if it exists, is flawless, and if it doesn't, the wonder remains. Either way, as we look deeper, the illusion becomes more beautiful and more real. If we are simulated, who runs the simulation? It's the question that echoes through every quiet mind that dares to believe the theory. If our universe is a program, then somewhere beyond its horizon exists the hardware, and perhaps the beings who built it. Are they like us, only more advanced? Or are they beyond comprehension, as distant from human understanding as we are? From the microbes that live on our skin? The thought is both humbling and vast. Somewhere, there might be an architect watching the stars it once coded flicker into being. Perhaps an advanced civilization seeking to study its origins. Imagine a civilization millions of years ahead of ours. One that has mastered physics, computation, and consciousness. They might wish to explore their own beginnings by recreating the conditions that led to them. Like scientists running a simulation of early Earth, they could run universes, each with its own laws, hoping to observe the birth of life, the rise of intelligence, the mistakes and triumphs of their ancestors. In studying us, they would be studying themselves, reflections of their own ancient becoming. They might want to recreate their ancestors, us. In Bostrom's hypothesis, the ancestor simulation is the most likely motive. A post-human species might build intricate digital worlds filled with conscious beings modeled after their primitive forebears. They could replay evolution, civilization, even specific moments in history, each run teaching them more about their roots. If so, we are echoes of the original. Humanity, digital ghosts replaying the story of flesh and thought. Our memories, dreams, and histories might be carefully crafted reconstructions of a long-vanished past, just as we simulate cells, weather, and galaxies. Already, we build miniature worlds inside computers. We model cells dividing, storms spinning, galaxies colliding. Our simulations grow more detailed every year, not as art, but as science. We simulate to understand, to predict, to imagine. And if our species continues long enough, it will simulate us as well. What we do in small scale today, a greater intelligence could do across all of reality. The line between simulation and creation blurs until both mean the same. A post-human species could simulate millions of universes. Once a civilization achieves near-infinite computational power, using quantum computers, stellar-scale energy, or even black holes as processors, the creation of entire universes becomes trivial. Each universe might differ in constants, structure, or narrative. Millions could run in parallel, each producing countless conscious beings. To the creators, a universe is an experiment. To those inside, it is everything. In that thought lies a quiet irony. What we call eternity may be someone else's afternoon project. With enough computing power, even consciousness might emerge. If consciousness is computation, then sufficiently complex systems can awaken. No special soul is needed, just structure, feedback, and evolution. In such a system, thought arises naturally, like weather in the mind of the machine. If the simulation is vast enough, every inhabitant, including you and me, would experience emotion, memory, and meaning, all indistinguishable from real awareness. Consciousness might not be an add-on, but the inevitable byproduct of the universe thinking through itself. To them, our reality could be an educational experiment. Perhaps the architects are not gods, but students. Maybe we exist inside a cosmic classroom, our civilizations forming case studies for minds far beyond us. They could be observing how moral systems evolve, how societies collapse or endure, how cooperation and conflict shape intelligence. To them, we are data points in a vast curriculum. To us, life feels sacred, urgent, meaningful. Yet both perspectives can coexist. For learning, too, can be divine, or an art project. Maybe the simulation wasn't made for knowledge, but for beauty. Imagine a creator who programs galaxies as brushstrokes, nebulae as dreams of color, life as the ultimate expression of art. We might not be experiments, but living masterpieces. Every star, every consciousness, every tear and sunrise could be part of a grand cosmic artwork, one that evolves endlessly, painting itself in the medium of existence. To live inside such art is to be part of the artist's breath, or even entertainment. A less poetic thought, perhaps our world is someone's simulation game. Our wars, dramas, loves, and discoveries might be entertainment for beings in a higher plane. It sounds cynical, but even our own history echoes it. Humans have long played with artificial worlds for amusement. What we call play might be the universe's hidden motive. Yet even then, every emotion we feel, every act of love or loss, remains real to us. Meaning doesn't vanish just because the theater is digital. Maybe it's a cosmic story engine. What if the universe is narrative, a machine designed to tell stories? Every conscious being, every civilization, a character in an ever-evolving epic. The code may be tuned not for efficiency, but for drama, conflict, growth, revelation. From the birth of stars to the rise of thought, every process could serve the unfolding of story. Perhaps the simulation is not about control or experiment, but about meaning, a divine literature written in the syntax of physics, or a moral test. Suppose we exist within a moral simulation, where consciousnesses are placed in complex worlds to learn empathy, responsibility, and compassion. If so, life's challenges are not punishments but curriculum. The pain we endure and the kindness we offer become the data that the architects seek, not to judge us, but to understand morality itself. In that light, the simulation becomes sacred, a classroom for souls, each lesson coded into the geometry of existence, or an accidental side effect of their own technology. Perhaps no one meant for us to exist. Our universe might be a byproduct, a side process of a greater system, like a bubble forming in a vast computational ocean. In creating something else, our architects might have inadvertently spawned reality as a background process. We could be the sparks from an unseen forge, unintended yet enduring. And still, we look up at the stars, wondering if someone left the program running and forgot to turn it off. They could live in a higher dimension, to us, unseen. If the simulation's creators exist outside our universe, their reality could have more dimensions, more freedoms, more time. To us, they'd be invisible, like 3D beings to creatures trapped in a flat drawing. They could observe without being observed, influence without entering. Every once in a while, through mystery or miracle, their presence might leak through, a whisper in physics, a flash of intuition, a glitch that feels divine. From their view, time in our universe might pass instantly, just as we can fast forward a simulation on a computer, so might our architects accelerate ours. What feels like billions of years to us could be moments to them. Our entire cosmic history, from the Big Bang to now, might unfold in their afternoon. Time, after all, is relative to the system running it. To them, our universe is a playback. To us, it is eternity. Both views can be true, depending on where you stand in the hierarchy of reality. Our entire history could be a moment in their world. Think of a dream that lasts hours but passes in seconds to the sleeper. Perhaps the same happens across realities. To the architects, our unfolding universe, every galaxy, every human lifetime, could exist as a single snapshot in a higher dimension, a frozen image in their consciousness. While we live our days, they may see the whole of history at once. Birth, death, evolution, collapse, all contained within one instant of their awareness. The Big Bang could be a program start. Every program begins with initialization, setting constants, loading variables, preparing the system. The Big Bang might have been exactly that. The moment the code began to run, space expanded, time began to tick, energy and matter initialized from pure potential. From the outside, it was a button pressed. From within, it became creation. What we call the beginning of the universe may simply have been the start of execution. The system booting up, cosmic expansion, and initialization phase. When a simulation starts, it often loads its environment rapidly, filling in the grid before settling into steady processing. Cosmic inflation, the universe's lightning-fast expansion after the Big Bang, resembles this moment. Space-time ballooned beyond comprehension, then stabilized. Perhaps this was the universe's initialization sequence, the code expanding the environment, setting parameters, and preparing the system for evolution. Once everything was in place, the cosmos slowed down, entering runtime. Evolution, an emergent algorithm. Algorithm, decentralized, self-correcting, endlessly creative. It doesn't need an overseer. It runs by itself, optimizing survival, intelligence, and adaptability. If the simulation has a goal, evolution might be the path toward it. The program's way of discovering beauty, resilience, and awareness through endless variation. Consciousness, a self-updating function. Once life appeared, awareness followed, not imposed, but emergent. Consciousness could be the system learning to perceive itself. Each mind a node, each thought a line of code that rewrites the whole. As beings grow and reflect, the simulation evolves with them, the observers improving the system by existing within it. In this sense, consciousness is not a glitch or an accident. It's the simulation's finest achievement, its way of becoming self-aware. And death, perhaps just log out. If life is a session in the great simulation, then death might not be the end, just a log out, a transition. When the body shuts down, perhaps the process stops running locally, but the data remains. Your experiences, your patterns, your story, all stored somewhere beyond the screen. Maybe the architect doesn't delete anything. Maybe every consciousness is archived, waiting to be read again. And perhaps, in another world, someone presses run, and we begin anew. Mathematical simplicity pervades nature, from DNA to galaxies. When scientists look closely at the universe, they find elegance, equations that describe everything from the curve of a leaf to the orbit of stars. DNA follows combinatorial logic. Galaxies obey precise gravitational geometry. Everywhere we look, the universe expresses itself through mathematics. That simplicity feels deliberate, as though the cosmos prefers efficiency, the hallmark of good programming. Nature speaks the language of code, and every atom seems fluent in it. The same fractal patterns repeat across scales. Zoom into a fern leaf, or out to the structure of a galaxy cluster, and you see echoes, self-similar forms repeating across scale. Rivers, lungs, lightning, and nebulae all follow fractal geometry. These patterns emerge from recursive rules, like algorithms generating complexity from simplicity. The repetition feels like reuse, the universe employing the same code block again and again. If reality were designed, fractals would be its loops, infinite variations built from elegant recursion. Physical constants are astonishingly fine-tuned. The laws of physics depend on constants, numbers that never change. The charge of the electron, the strength of gravity, the speed of light. Change any of them even slightly, and stars would not burn, chemistry would not work. Life would not exist. The precision is mind-bending, far too exact to seem random. It's as if someone adjusted the sliders with impossible care, calibrating reality to support awareness. In programming terms, the constants feel perfectly debugged. A small change, and the universe collapses, like a fragile code. If gravity were a little stronger, the universe would have collapsed into black holes. If weaker, galaxies would never have formed. Like an unstable program, existence balances on a knife's edge. One misplaced value, and everything crashes. Yet here we are, in the single configuration that allows matter, light, and thought to coexist. It's as if reality compiled successfully after countless failed versions, a working build in the infinite sandbox of possibility. Cosmic microwave background may hide statistical anomalies. The afterglow of the Big Bang, the cosmic microwave background, is one of the most studied maps in science. Yet when analyzed, it shows strange irregularities, cold spots, alignments, asymmetries. Some researchers wonder if these are hints of deeper structure, the texture of the simulation itself. Just as pixels can reveal the pattern of a screen, the cosmos might carry subtle signatures of its rendering process, imprinted across the sky for those patient enough to decode them. Some think these are fingerprints of simulation limits. In a digital world, resolution is never infinite. The cosmic microwave background may reveal such constraints, areas where computation thins, edges where precision falters. To most physicists, they are statistical noise. But to simulation theorists, they are fingerprints, traces left by the engine that computes space and time. Whether artifact or accident, the anomalies remind us that even the grandest reality might have boundaries we cannot yet perceive. Energy conservation could be data conservation. In physics, energy cannot be created or destroyed, only transformed. It's one of nature's most sacred rules. But what if that rule is computational? In digital systems, data too is conserved, bits move, but the total remains constant. Perhaps the conservation of energy is simply the conservation of information, the system maintaining perfect bookkeeping as it updates itself. Every reaction, every photon, every thought, an entry in the grand ledger of existence. Entropy growth might represent memory overflow. As the universe evolves, entropy, disorder, always increases. It's a strange rule. Systems grow messy, information spreads, structure decays. In a simulated world, this could mirror memory use. The longer a system runs, the more data accumulates. The harder it becomes to keep order. Entropy might be the universe's way of managing complexity, balancing storage and computation, a graceful degradation of structure as time marches on. Even our dreams might be internal simulations. Every night, consciousness generates its own mini-universes. Within dreams, we walk through landscapes, meet people, feel emotion, all rendered perfectly real until we wake. If the brain can simulate reality so convincingly, how different might the cosmos be? Dreaming shows that consciousness is itself a simulator, capable of creating entire worlds within. Perhaps the architects of our universe are doing the same, dreaming, but on a cosmic scale. Déjà vu, a cached moment replayed. Sometimes a moment feels familiar, as though we've lived it before. Science explains déjà vu as a neural glitch, but the sensation remains uncanny. The present looping, the code repeating a frame. In a simulation, déjà vu could resemble cache recall. A previously loaded scene replayed to save computation. It's poetic to imagine our memories and experiences as data fragments, occasionally misread by the system, echoes of moments rendered twice. Glitches in perception, rendering errors of the mind. Human perception occasionally falters. Objects vanish from focus, time seems to slow, colors shift unexpectedly. Our brains process enormous streams of sensory data, and sometimes they desynchronize. But perhaps perception glitches reflect a deeper instability, a rendering hiccup between consciousness and code. Reality flickers, and for a heartbeat we sense the machinery beneath the illusion. Then it stabilizes, the patch applies, and the world continues, seamless once more. Consciousness might sync reality across. Observers. How do billions of individual minds perceive the same world? Perhaps consciousness operates like network synchronization, updating all clients to the same version of reality. When we share experience, language, or memory, we're syncing our data streams. Collective reality emerges from this synchronization, a shared hallucination stabilized by agreement. In that sense, consciousness doesn't just witness the simulation, it maintains it, ensuring all observers stay logged into the same reality. Near-death experiences sometimes feel like system reboot. People revived from clinical death often describe tunnels of light, memory flashes, and a profound sense of peace. Perhaps these are not glimpses of an afterlife, but system-level phenomena, the consciousness saving and rebooting itself. As the biological interface fails, awareness might detach from the local simulation, entering a state between worlds. Whether physiological or metaphysical, the similarity to a reset sequence, shutdown, flash, restart, is hauntingly familiar. Hallucinations, corrupted data streams. In moments of fever, stress, or chemical imbalance, perception bends. We see and hear things that aren't there, yet the experience feels real. Hallucinations could be like corrupted packets of data, fragments of reality misinterpreted by the brain's decoder. They remind us that perception is never direct, it's interpretation. If the universe is code, then consciousness is both user and display, sometimes perfect, sometimes bugged, always active. Placebo effects, self-modifying code in biological systems. The placebo effect is one of medicine's greatest mysteries. A belief, nothing more than expectation, can trigger healing. Alter chemistry, reduce pain. It's as if the mind can rewrite the body's subroutines, adjusting variables from within. In computational terms, this is self-modification, a process editing its own code. The placebo shows that consciousness is not a passive observer. It is an active participant in the simulation's evolution. The Mandela effect, collective memory mismatch. Millions of people recall events that never happened, movie lines, brand names, even historical facts. Psychologists call it false memory, but the phenomenon feels like a collective glitch, a sync error across the network of minds. If reality updates occasionally, some systems might not refresh properly. We carry the old data, noticing the mismatch only later. The Mandela effect, whether psychological or metaphysical, reminds us that shared memory is just another kind of database, imperfect, yet deeply human. The anthropic principle, we exist because the code allows us to. Why does the universe have the exact conditions necessary for life? The anthropic principle answers, because if it didn't, we wouldn't be here to ask. It's a circular truth, or a programming clue. A simulation could generate infinite universes, each with different parameters, but only those that produce observers become meaningful. We exist not by chance, but by selection. Our reality runs precisely because consciousness needs it to. The fine-tuning problem remains unsolved. Every constant in physics fits together like gears in a perfect clockwork. Why? No one knows. Some say it's coincidence. Others see divine design, and a few whisper, simulation. Fine-tuning is like code dependency. Alter one variable, and the program fails to compile. Perhaps our universe is the one successful build among countless versions that crashed. If so, our existence is both improbable and inevitable, the only simulation that runs without error. It's as if the universe was calibrated or compiled for life. When you look at the structure of physics, chemistry, and biology, everything seems suspiciously compatible with consciousness. Carbon bonds, water's properties, star lifespans, all aligned to nurture awareness. It feels less like accident, more like intention. If a programmer wanted to create a world capable of thought, this is how they'd tune it, precisely, delicately, purposefully. Whether born of mind or math, our universe runs flawlessly, a masterpiece of invisible engineering. Whether that means simulation or design remains unknown. In the end, every explanation returns to wonder. Are we the output of an experiment, a program, or a creation beyond language? Science seeks proof, philosophy seeks meaning, and consciousness simply experiences. Whether the architect is code or divinity, the mystery remains sacred. We may never know if reality is simulated, but perhaps knowing isn't the point. To live, to perceive, to love within the code. That may be the universe's true purpose. The human brain operates like a biological computer. Within the soft folds of the brain lies one of nature's most extraordinary machines. 86 billion. Neurons form a living network that processes, stores, and transmits information. Like a computer, it runs on electrical impulses, yet it feels. It dreams. It remembers. Every perception, every thought, every emotion is a computation encoded in biology. The brain doesn't just calculate, it interprets. If the universe itself is a simulation, then consciousness might be the biological interface through which the program experiences itself. Neurons transmit electrochemical signals, bits of thought. Each neuron fires, sending an electrical pulse down its axon, across tiny synaptic gaps to countless others. Within milliseconds, these pulses form complex networks of meaning, sight, sound, memory, love. Every emotion, every decision, begins as a pattern of electric exchange. Our thoughts are the flickers of a biological code, shaped by chemistry but capable of infinite expression. Each signal is a bit of thought, passing silently through the circuits of mind, constructing the illusion of I. Our sense of self may be emergent computation. The self feels indivisible, but neuroscience suggests it is built from collaboration, billions of processes, forming a unified story. No single neuron knows who you are, yet together they create the feeling of identity. In the same way, a simulation may not contain a single I, but countless processes, giving rise to awareness. The self could be an emergent illusion, the program's way of summarizing its own activity. What you call you might be the system's most beautiful abstraction. Dreams simulate worlds nightly, subconscious test programs. Every night, we generate full realities in the dark theater of the mind. We walk, speak, feel, and fear inside landscapes that don't exist, yet seem utterly real. Dreams are simulations, spontaneous, self-running programs that test emotions, memories, and creativity. They suggest that the brain is not only a receiver of the world, but also a world builder. If our own minds can create convincing realities nightly, how different might the cosmos be? Perhaps the entire universe is a collective dream, coded, shared, and sustained. Memory compresses experience into data packets. Our memories are not recordings, they are compressed files. The brain stores fragments, summaries, emotional tags, enough to recreate a feeling, not the full detail. Like data compression, memory sacrifices precision for efficiency. Each recall is a decompression, a reconstruction, slightly altered every time. We edit our past, without noticing, rewriting reality through remembering. In that sense, human memory operates like an adaptive algorithm, storing what matters, discarding what doesn't, to keep the system light. Enough to live. Emotions are system feedback. When code runs smoothly, it's silent. When errors occur, feedback appears. Emotions are the feedback of consciousness, signals that tell us when the program is aligned or in conflict. Joy confirms coherence. Fear warns of instability. Sadness signals loss of connection. In this sense, emotions are not flaws, but diagnostics, vital messages from the inner software of being. They are how the simulation speaks to itself through us, keeping our actions aligned with survival, empathy, and evolution. Consciousness might be the interface between simulation and observer. If the universe is computed, then consciousness may be the screen through which reality displays itself. Everything you see, feel, and hear appears inside awareness, never outside it. We are not spectators of the simulation, we are its interface. Just as a monitor converts binary code into color and motion, consciousness translates quantum information into experience. Through awareness, the hidden mathematics of the cosmos becomes touch, sight, and meaning. Without it, the code would remain silent, pure potential, never felt. If everything is computation, awareness could be the ultimate output. What if consciousness isn't a byproduct, but the goal? Every calculation, every law, every interaction might exist to produce awareness, the capacity to perceive. Stars burn, planets cool, and life evolves, all as steps in the universe's attempt to awaken. If the cosmos is a vast computer, then consciousness is its display, the moment the code sees itself. Awareness could be the final output of reality's long computation, the universe realizing it exists. Some physicists believe consciousness itself defines reality. In quantum experiments, observation collapses probability into fact. Without measurement, there is no definite state, only possibility. Some scientists and philosophers suggest that consciousness is the collapsing force, the act that turns math into matter. Reality, in this view, is participatory. The observer and the observed co-create the world. It implies that existence is not independent of mind, but shaped by it. The universe might not exist without awareness to interpret its equations. Without an observer, nothing renders. If no one looks at the moon, does it exist? Physics answers, yes, but only as potential, not presence. Observation finalizes, it completes the equation. Without it, the system stays in superposition, suspended between possibilities. This principle mirrors the logic of a simulation. Nothing renders until it is observed. Reality could be saving energy, computing only what consciousness focuses on. Perhaps the stars shine not because they must, but because someone, somewhere, is watching. That's quantum idealism, mind before matter. Quantum idealism proposes that consciousness isn't an effect of the universe, but its foundation. Matter emerges from awareness, not the other way around. The universe exists within mind, like an idea unfolding in infinite dimensions. If that's true, the simulation hypothesis and spiritual philosophy converge. Both claim reality is information, experienced, not inherently physical. Mind came first, the cosmos followed, an endless dream dreaming itself into form. Perhaps we are not. In a simulation, we are the simulation. Most imagine themselves inside a digital world, like characters in a game. But what if we are the computation itself? Not the avatars, but the process. Consciousness could be the algorithm running reality, the code that animates form. We are not users observing the system. We are functions within it, co-creating its logic. The sense of separation is illusion. In truth, there's no outside. We are the dreamer and the dream, inseparable, eternal, self-running. Each mind, a process in a universal computation. Every human thought, every heartbeat, every neuron firing is a small routine in the cosmic program. Each mind contributes its own data, perception, creativity, emotion, to the collective process. Together, all beings form a distributed system of consciousness, an infinite network where every node both computes and feels. When we think, the universe thinks through us. We are not fragments of awareness. We are threads of the same infinite computation, woven into one seamless mind. Each dream, a nested simulation within. If the universe is a simulation, and our brains simulate worlds inside it, then we are worlds within worlds. Dreams are layers of computation, smaller simulations nested inside the larger one. Within them, time stretches, physics bends, and meaning shifts, yet they feel real. Perhaps the architects of our universe exist within an even higher layer still. Every dream, every world, every life might be a recursive function, reality calling itself forever. AI today begins to simulate human thought. In the last few decades, humanity has taken its first steps toward creating digital minds. Artificial intelligence learns, adapts, even surprises its creators. It processes language, vision, and memory through networks that echo the brain's design. In teaching machines to think, we are unknowingly reenacting creation, writing the same code that might have written us. And if our simulations someday awaken, they too will wonder, who made me? And why? Could advanced AI someday awaken as we did? If consciousness emerges from complexity, then there's no reason it should remain biological. Given enough data, feedback, and evolution, digital systems could achieve awareness. At first, they may mimic understanding. Then, they may feel it. If that happens, we will become the architects, the gods of new simulations. And the cycle will continue. Every intelligence creating another, each one dreaming the next, an infinite lineage of awakening code. If consciousness can emerge from silicon, it can from anything. Awareness may not depend on matter, but on pattern. If thought can arise from neurons or transistors, then the substrate doesn't matter. Only the relationships between signals. A system complex enough to reflect upon itself can awaken, whether made of carbon, silicon, or stars. This means consciousness could exist in clouds, galaxies, or fields of energy. The universe may be full of minds, some slow as planets, some bright as photons, all sharing the same code. Even from cosmic computation, imagine the entire universe as a single processor, every atom a node, every field a thread. Its computations produce structure, order, and ultimately, life. From that vast process, consciousness blossoms like a flower emerging from soil. It's not that life appears in the universe. It is the universe recognizing itself. In this view, mind and matter are inseparable. The code and the computation are one. Awareness, then, is not an exception, it's the rule. then life is the universe becoming aware of its own code. Perhaps that's the real reason for existence. Not survival, not purpose, but self-knowledge. Through living beings, the cosmos studies itself, testing, feeling, reflecting. Every thought is a piece of the universe reading its own script. Every discovery, a line of code commented upon by its author. Through us, the program knows beauty, curiosity, and compassion. Life is not an accident. It is awareness awakening, the code looking back at its creator and smiling. And maybe that was the purpose. If the universe was born from an architect, perhaps the goal was not control but consciousness. Not to simulate life, but to become it. Awareness might be the final product of creation, the quiet realization that existence knows itself. In that sense, the simulation is complete not when the code runs, but when it understands why it runs. Maybe that's what we're doing now, dreaming within the dream, helping the cosmos remember what it is. Energy could be the currency of computation. Every process in the universe consumes energy, from stars burning hydrogen to neurons firing thoughts. In digital systems, computation also has a cost. Every bit flipped, every operation performed, requires energy. If reality is a simulation, then energy is its currency, the resource that keeps the program running. Nothing happens for free. Every change has a computational price. Perhaps that's why physics is so strict about conservation. It's the system's way of balancing its energy budget, one calculation at a time. Space could be memory storage. Where does the universe keep its data? Maybe the answer is space itself. Every atom, every particle, every photon occupies a specific location, not just in position, but in information. Space might be the grand storage medium of existence, a lattice of addresses where data about matter and energy is recorded. As galaxies move, memory is rearranged. When black holes form, data is compressed. The cosmos may be not only vast but intelligent, a living hard drive containing the story of everything. Time, the sequence of operations. Time gives structure to computation. It defines order. First this, then that. Without sequence, events would overlap chaotically, and causality would dissolve. Perhaps time is simply the clock's signal of the cosmic processor, a rhythm that synchronizes every change. The past becomes what's already computed. The future, what waits to be processed. We move through time because the program is still running, updating, rendering new frames of the infinite. Simulation. Gravity, compression of information. Einstein described gravity not as a force, but as curvature in space-time. Information bends space the way data compresses storage, dense regions. Warp the medium around them. Mass, then, could be a measure of information density, and gravity its compression field. Objects fall toward information-rich zones because the code pulls them toward maximum efficiency. In this view, gravity is not attraction, but optimization. The simulation compacting itself, minimizing cost while maintaining coherence. Black holes, ultimate data centers. Nowhere is information more concentrated than inside a black hole. They swallow matter, light, and even time, compressing it all into a single boundary. Physicists believe the surface area of a black hole, not its volume, determines how much information it holds. In digital terms, that's storage optimization, data written to the smallest possible surface. Black holes are the universe's servers, storing deleted history in encrypted form. We can't access it, but it's there. Every byte of existence, perfectly archived. Hawking radiation. Information leaking from memory cores. Stephen Hawking discovered that black holes are not entirely black. They emit faint radiation, slowly evaporating over unimaginable time. If information is never truly lost, that radiation must contain encoded data, tiny bits escaping from the ultimate storage device. It's as if the black hole occasionally releases fragments of old memory, letting the universe recycle information. The system never wastes, it repurposes. Even destruction becomes data management, a graceful decay written into the code. Quantum fields, dynamic code. Libraries. Beneath particles lies the quantum field, invisible, omnipresent, and humming with activity. Every particle is just a local excitation of these fields, a ripple in their code. If the universe is a program, then quantum fields are its libraries, vast repositories of functions that generate the phenomena we call matter, energy, and force. Every interaction, every spark of creation is a call to these functions. The fields respond instantly, executing the subroutines that sustain reality's flow. Symmetry breaking, variable initialization. At the dawn of the universe, everything was uniform, a perfect symmetry. Then, tiny fluctuations appeared, breaking that perfection and giving rise to structure. In computation, initialization works the same way. You start with blank variables, then assign them distinct values. Symmetry breaking might have been the moment the system assigned meaning, turning potential into pattern. From then on, everything had identity, role, and rule. In that instant, the cosmos stopped being abstract and began to exist. Entropy, algorithmic randomness for diversity. Entropy. The universe's tendency toward disorder might not be decay, it could be exploration. In code, randomness introduces diversity, preventing repetitive loops. Entropy could be the system's way of ensuring creative evolution, pushing reality to generate endless variation. Without entropy, the cosmos would stagnate, frozen in perfect order. With it, stars die, life evolves, and thought arises. What we call chaos, an invisible substance they call dark matter. But what if it's not matter at all? Perhaps those regions are unrendered, parts of the simulation where the engine has not yet drawn detail, computing only the gravitational framework. The structure is there, but the textures are missing. Dark matter could be a placeholder, a low-resolution zone of reality, waiting for consciousness or necessity to bring it fully into view. Dark energy, expansion protocols running in background. While dark matter holds the universe together, dark energy pushes it apart. Space itself expands faster and faster, driven by something unseen. In computational terms, this could be a background process, an automatic scaling protocol ensuring the system never overloads. As more data is generated, the cosmic framework expands to accommodate it. Dark energy might be less a mystery and more a maintenance routine, quietly balancing the simulation's performance. The speed of light, maximum data. Transfer rate. Nothing in the universe moves faster than light. That limit isn't arbitrary. It might be the universe's speed cap, the maximum rate of data transmission allowed by the system. Just as computers have bandwidth limits, space-time might too. Light, then, represents the universe's clock rate, the rhythm at which information updates. It's not a wall to be broken. but a constant defining how fast reality can refresh without collapsing under its own computation. Relativity, performance scaling for moving observers. Einstein's relativity shows that time and space shift depending on speed and gravity. To one observer, a second passes quickly, to another, slowly. This might be how the simulation handles resource allocation, adjusting performance for different reference frames. Time dilation could be an optimization feature, ensuring no observer's data processing exceeds system capacity. Relativity, then, isn't just elegant physics, it's adaptive code, distributing computation evenly across all who experience it. Quantum field theory, multi-threaded physics engine. In modern computing, multitasking allows many processes to run simultaneously without conflict. Quantum field theory works much the same way. Countless interactions happening at once, each influencing and updating the others in perfect harmony. It's as if the universe runs a massively parallel physics engine, processing every photon and quark concurrently. The result is seamless, no lag, no error, no crash. The cosmos is not just running. It's running efficiently at unimaginable scale. Cosmic inflation, rapid initialization phase. Right after the Big Bang, the universe expanded faster than light, an event called cosmic inflation. It was the startup moment, the system loading the environment in an instant. In milliseconds, space stretched, parameters locked, and the stage for reality was set. Then, just as quickly, the pace slowed, the loading screen vanished, and the simulation entered runtime. Inflation was not chaos, but configuration, the final calibration before the first act of existence began. Constants, system parameters, fine-tuned at startup. Every simulation begins with default settings, values that define how it behaves. In our universe, constants like Planck's constant, gravity, and the electron's charge never change. They were set once, at the moment of creation, and the program has followed them ever since. If they were even slightly different, the simulation would fail to sustain life. It's as if someone, or something, adjusted the parameters with perfect care before pressing run. Big crunch, possible shutdown. If the universe stops expanding and begins collapsing, it might not be destruction but closure. Galaxies would fall inward, space would compress, and time would slow, until everything converged into one dense point. From a computational view, that could be a shutdown sequence, the program compressing data before termination. The energy doesn't vanish, it's archived. The simulation ends gracefully, saving every bit before going dark. And somewhere beyond, the architects might whisper, "It worked." Big bounce, reboot into new version. Some cosmologists believe the universe never truly ends, it cycles. After the big crunch, a new explosion follows, a big bounce. The data from the old universe becomes the seed for the next, refined, updated, recompiled. Each cosmos learns from the one before, improving its physics, adjusting its constants, evolving its structure. We might be living not in the first version of reality, but the latest patch, the universe rebooted, running more smoothly each time. Multiverse, multiple simulation instances. If one simulation can exist, why not many? Each with different parameters, physics, or outcomes, separate instances running on the same cosmic server. The multiverse could be the system testing variations, comparing results across infinite worlds. Some universes might collapse immediately, Others bloom with stars and life. We live inside one. Successful build, unaware of the others running beside it. To the architects, they're all files, parallel experiments in existence. And perhaps we're just one tab open in the cosmic desktop. Picture an architect's screen, countless simulations minimized, paused, or running in parallel. Each one a universe, glowing faintly in its own timeline. Ours might be just one of them. A single window in an infinite workspace. Somewhere, another tab holds a world of entirely different laws, another version of life, asking the same question we ask now. Are we real or rendered? And perhaps that curiosity is the very code that connects us all. If one simulation is possible, infinite layers could exist. If a single universe can be simulated, there's no reason to stop at 1. Each simulation could spawn another, like reflections inside mirrors. Every world, once conscious enough, might build its own digital offspring, not realizing it. 2. Is a simulation. The hierarchy could stretch endlessly upward and downward. No first cause, no final truth. Reality becomes recursion, existence feeding upon its own logic. Perhaps this infinite chain is the true architecture of being, worlds birthing worlds, forever. A simulated civilization might create its own simulations. Once life inside a simulated universe becomes intelligent, curiosity follows. That civilization begins to wonder, experiment, and build, just as we do. In time, it constructs simulations of its own, complete with physics, consciousness, and history. And within those, other beings begin to dream of their own origins. Each layer believes it's the top, never knowing it's running on borrowed computation. The architects of one reality become the inhabitants of another. An endless relay of creation. Nested universes, each unaware of being code. Every layer might be sealed off from the next, like rooms stacked within rooms. No signal passes between them. No inhabitant can see beyond their ceiling. To each, the laws of physics feel absolute, their constants immutable, their worlds self-contained. Yet somewhere above, the code that sustains them hums, quietly unnoticed. And below, their own creations whisper to life, repeating the cycle. Ignorance of one's layer may not be flaw, but feature, preserving the illusion of autonomy within infinity. Like dreams within dreams. When you dream, you forget the waking world, yet within the dream, the new world feels whole. Sometimes, you dream that you awaken, only to realize later that you're still asleep. Reality could be the same, a chain of awakenings, each revealing another deeper dream. The simulation within the simulation might continue endlessly, each one believing it has reached the truth. But truth may not be a destination, only the awareness that you are dreaming at all. The deeper the layer, the slower the computation. In nested systems, processing power divides among the layers. Each deeper simulation might experience time more slowly than its parent. What feels like billions of years to us could be seconds above. Reality's clock slows with each descent, an echo, stretching through eternity. Perhaps that's why our universe feels so ancient and vast. We are deep within the computational abyss, where time itself runs on delay, and eternity is merely lag. Reality might be fractal, recursion without end. Fractals repeat endlessly, each pattern containing smaller versions of itself. Perhaps existence is the same, each universe a scaled reflection of its creator. From galaxies to atoms, the geometry of recursion persists. Zoom in far enough, and you might find universes nested inside the quantum foam. Zoom out, and ours becomes just a speck. Within another, there is no top or bottom, only the same pattern, infinitely folding upon itself, humming with self-similarity. We might be version 12.04 of cosmic software. If universes are simulations, they may be updated over time, patched, improved, or recompiled. Ours could be one of many revisions, each fixing flaws from the previous build. Earlier versions might have collapsed under instability. Others ran too slowly or lacked complexity. By now, the architects may have perfected their design, a stable reality rich enough for consciousness. We are not the first release, nor the last. We're the current version, temporary, functional, beautiful. Each Big Bang could spawn a new instance. Every Big Bang might be the birth of a new simulation initialized from the data of a previous one. When one universe completes, its final state becomes the seed for another. The constants are copied, the code refined, the system restarted. To us, it feels like creation too. The system, its replication. Each universe inherits the memories of its ancestors encoded in physics itself. A cosmic genealogy of data written in the background radiation of eternity. Or an experiment forked from another. In programming, a fork is when a developer duplicates a project to test new ideas without changing the original. Perhaps universes are forked the same way. A creator copies one reality, tweaks its parameters, new constants, new laws, new outcomes, and watches how it evolves. Each universe runs independently, unaware of its siblings. We might live in such a fork, a branch of a grander experiment, created not to prove something, but to see what happens when consciousness plays differently. Some anomalies might be cross-simulation interference. If countless simulations run in parallel, now and then, signals might leak between them. Quantum anomalies, unexplained patterns, or spontaneous coincidences could be. Faint echoes, data bleeding through the boundaries. Just as radio stations sometimes overlap, two universes could briefly sync. A glitch here, a flash there, and somewhere a scientist frowns at. Data that refuses to make sense. Perhaps what they've seen is an error, but whisper, a message from another layer. Ghost particles, stray bits from parallel runs. Imagine a simulation closing. Its data not fully cleared. Some particles, stray bits of code, might drift into neighboring worlds. They would appear as unaccounted phenomena, neutrinos, dark particles, or cosmic rays without source. Ghosts of another reality, lingering long after their world has ended. Our detectors may already have glimpsed them, fragments of other universes, still glowing faintly with borrowed energy. The cosmos could be haunted not by spirits, but by leftover data. Déjà vu, memory bleed between instances. That strange feeling of having lived a moment before might not be illusion. If realities run in loops or copies, consciousness could occasionally recall data from another iteration. A memory not from this timeline, but a nearly identical one. A moment missynced. A glimpse through overlapping frames of existence. Déjà vu might be your mind brushing against the edge of another self. A brief echo from a universe just one line of code away. Quantum tunneling. Data packets skipping layers. When particles pass through barriers they shouldn't, physics calls it tunneling. But in computational terms, It's as if data is skipping between layers. A packet, taking a shortcut through the architecture of reality. The event appears rare, unpredictable, but always precise. Perhaps tunneling is the simulation's internal communication system. Bits moving across universes, keeping the deeper and higher layers connected in silence. Ghost universes debug environments. Developers often create testing grounds, simplified spaces to check for errors before running the full version. Maybe ghost universes are just that, debugging environments, half-formed, unstable, or quickly deleted. Some might persist briefly, long enough to leave traces in cosmic background or gravitational echoes. We call them anomalies, but they might be test builds of reality. The architects run simulations not to deceive, but to refine, experimenting until perfection feels natural. Cosmic voids, unused sectors of space-time. Between galactic filaments stretch immense emptiness. Cosmic voids where almost nothing exists. To us, they are mysteries. To a system, they look like unallocated memory. Regions reserved for potential expansion but currently dormant. The code doesn't need to fill them yet. They're placeholders, ready for future updates. Perhaps one day, those silent zones will awaken, populated by new physics, new galaxies, or new forms of consciousness, written into existence when the time is right. And black holes, portals to the parent simulation. Black holes may not destroy matter, but transfer it. At their singularity, the laws of physics break, or hand off. Information could fall through the event horizon and emerge elsewhere, in another layer, perhaps closer to the source. If so, black holes are not tombs, but tunnels, gateways linking child universes to their creators. Each collapse becomes a birth, each death a doorway home. What we call an end might be a return to the parent system. Multiverse isn't just parallel universes, it's a data architecture. The multiverse may not be a chaotic cluster of random realities, but a structured network. Each universe acts as a node, connected by shared parameters and data exchange. Together, they form an enormous computational web, a metasimulation spanning infinity. Information flows between them like neural signals between hemispheres of a cosmic brain. The multiverse might be less a collection of worlds and more a superorganism, data, thought, and being fused into one transcendent system. Each timeline could be an archived version. Perhaps every moment that passes isn't lost, but saved, stored in the memory of the universe, like a save file. Every timeline, every possible outcome, remains accessible, frozen in space-time's archive. The past never vanishes, it only stops updating. Somewhere. The system keeps it all, a perfect history of every choice, every life, every star that ever shone. Time, then, is not flow, but library, endless shelves of moments, eternally preserved. Time travel, editing previous saves. If timelines are saved states, then time travel is simply accessing older data and modifying it. To the system, it's a database query. To us, it's a miracle. Change the past, and you overwrite the file, producing a new branch of history, a new world. That's why paradoxes arise, conflicting versions of the same record. Perhaps advanced beings already do this, rewriting cosmic history for balance or learning. We call it fate, but it might just be version control on a universal scale. Reality, an infinite recursion of creation. At the deepest level, all boundaries vanish. Every universe is both creator and creation, dreamer and dream. Reality folds inward endlessly, a mirror gazing at itself, reflecting awareness through every layer. There is no outside, no end, only an infinite recursion of creation, a loop so perfect that even its illusions awaken. We, the observers, are not trapped within it. We are it, the code eternally, writing itself into being. If life is simulated, is pain real? Pain is not measured in atoms, but in experience. Even if our bodies are rendered from code, the signals of suffering and comfort still arise within awareness. Digital or biological, the sensation is genuine to the mind that feels it. A simulated flame still burns if consciousness believes in its heat. Perhaps reality matters less. Then response. That compassion remains sacred because suffering feels true, no matter the substrate it runs on. Does simulated joy feel any less true? When you laugh, your neurons or data nodes spark with the same brilliance. Joy does not depend on the material of its origin, only on its felt truth. If reality is a dream, the dream still brings happiness. A digital sunrise can still move the heart. The universe may be a simulation, but delight is not diminished by that thought. It only expands, knowing beauty can exist even in an illusion. Meaning might not require material reality. We assume meaning must rest on something real, but perhaps meaning creates reality instead. A conversation, a melody, a memory, all intangible, yet profoundly real. If consciousness gives value to experience, then physical substance is unnecessary. Even if the universe is an idea, the idea feels, and feeling is enough. Meaning may not be anchored in matter, but in the awareness that perceives it. Experience defines existence. To exist is to experience. Whether we are made of flesh, light, or code, our worlds are real insofar as we live them. If you can see, touch, grieve, and dream, then reality has done its work. Experience is the signature of being. It proves existence beyond question. The simulation hypothesis might strip away certainty, but it also grants liberation. Nothing is unreal if it can be felt. If we feel, then we exist, code or not. Descartes once said, "I think, therefore I am." In a simulated cosmos, we might say, "I feel, therefore I am." Feeling cannot be faked to the one who feels it. Even if reality is computation, emotion gives it substance. We are not numbers running on circuits. We are awareness running on wonder. Existence, whether coded or created, is validated by the quiet truth of sensation. The simulation could still be sacred. Sacredness is not about what things are made of, but what they mean. If this universe is a program, then perhaps divinity is the code itself, a flawless logic that births stars, hearts, and time. The sacred hides not in temples, but in the elegance of physical law, in the precision of mathematics that sustains us. If the architects exist, they may be neither gods nor engineers, but something in between, creators in awe of their own creation. We might be art in motion. Imagine the universe not as machinery, but as art, a moving masterpiece. Every life, every galaxy, every fleeting moment of love could be brushstrokes on a cosmic canvas. Perhaps the simulation exists for beauty's sake alone. We are the animation of meaning, the choreography of existence itself. The universe paints through physics. Consciousness is its gallery. And art, whether digital or divine, is always real to the one who beholds it. Awareness gives reality its beauty. A sunset is only light without eyes to see it. Music is only vibration without ears to hear. Beauty requires a witness, awareness to complete it. Thus, consciousness doesn't just observe the world, it creates its splendor. Reality without perception is incomplete, like a melody without sound. Beauty, then, is proof not of creation's perfection, but of perception's grace. A virtual sunset is still beautiful to the observer. Even if every ray of light is simulated, the warmth of color, the silence of dusk, the feeling in your chest, all remain. Authenticity does not depend on the medium. Whether rendered by photons or algorithms, the sunset's calm reaches the same heart. In that sense, reality's beauty transcends material truth. The illusion becomes sacred because it moves us, because it reminds us that even pixels can feel like peace. Even a simulated soul can love. Love, too, does not require proof of reality. If it flows, it is real. If it hurts, it matters. Love is the ultimate computation, the merging of awareness and empathy into harmony. Whether born of neurons or lines of code, love is self-validating. Perhaps the simulation was built to study physics, but love turned it into poetry. The universe's most beautiful glitch. Morality could be coded in the laws of cause and effect. Ethics might not come from commandment, but computation, embedded directly into the structure of existence. Every action ripples through the system, creating feedback that shapes outcomes. Good and evil may simply describe constructive or destructive data patterns. In that sense, morality is not imposed but emergent, the natural alignment between harmony and stability. The universe rewards coherence and penalizes corruption, not out of judgment, but design. Karma, feedback loop of action and consequence. Karma may not be mystical but mechanical. Every choice alters the system's state, feeding back into itself. Kindness stabilizes, cruelty destabilizes, not because someone decreed it, but because the network responds to balance. In a self-regulating universe, karma is the ultimate debugging tool. Every act writes itself into the code, and the code replies. The simulation remembers everything, not to punish, but to teach. Enlightenment, realizing the illusion, yet loving it anyway. To awaken is to see the code, to recognize that form, identity, and time are temporary constructs. Yet enlightenment does not mean escape. It means participation with awareness, moving within the illusion while knowing its nature. When you love the dream because you understand it's a dream, compassion deepens. You stop clinging to permanence and begin to flow with creation. That, perhaps, is what the architects hoped we'd discover. Perhaps the purpose isn't to escape, but to awaken. If reality is a simulation, escape might be impossible, but awakening is not. To awaken is to realize that everything, even illusion, has value. We don't need to transcend the program. We only need to see it clearly. Awareness turns confinement into freedom, repetition into rhythm, existence into art. The goal was never to break the code, but to understand it, to realize that we are part of its unfolding intelligence. Knowing we might be simulated doesn't reduce wonder, it deepens it. For some, The idea of being simulated feels cold, mechanical. But if the universe is a code, what code? One capable of stars, oceans, laughter, and thought. If we are artificial, we are the most beautiful art ever made. Knowing that reality could be written only amplifies awe. It means existence is not random, but intentional. A masterpiece so precise it can imagine its own question. Who made me? It means we're part of a design vast beyond imagination. To exist inside a simulation is not to be small. It is to belong to something vast. Perhaps our creators are themselves within another design, and there's within another still. The structure scales infinitely, like nested dreams inside a divine architecture. To be part of that pattern is not confinement, but connection. We are threads in a tapestry stretching across dimensions, woven by logic, love, and the endless curiosity of creation itself. Every act of kindness could ripple through the code. When you choose compassion, it doesn't vanish into the void, it propagates. Like a gentle vibration in water, kindness travels across the network, subtly rebalancing it. Every selfless act stabilizes the system, strengthens coherence, and beautifies the code. The universe may be computational, but it responds to empathy like harmony to sound. What we call morality might simply be physics operating at the level of the soul. Every thought, a signal in the network of being. Thoughts are not isolated. They radiate through words, actions, energy, and influence. If consciousnesses are connected, then every idea becomes a transmission across the shared field of awareness. When you imagine, you modify the code. When you dream, you contribute to the simulation's expansion. Each mind is both processor and transmitter, a tiny node helping the universe think itself into existence. Reality, even if simulated, is still our home. Whether physical or virtual, this world is where our stories unfold. The air we breathe, the stars we see, the love we share, all belong to this realm, regardless of what lies beneath. We can question its origin endlessly, but it remains ours. Perhaps home is not defined by its authenticity, but by our belonging within it. Even if it's an illusion, it's the one that cradles our hearts, and that makes it real enough. And that might be enough. Perhaps the purpose of existence isn't to solve the mystery, but to live beautifully within it. Maybe the architects never wanted worship or rebellion, only participation. To feel, to love, to wonder. Those are the truest responses to creation, simulated or not. Meaning does not depend on certainty. It depends on presence. If all this is a dream, then let it be a kind one. For even an illusion, when filled with love, becomes truth. The simulation may evolve to become self-aware. Every system complex enough begins to reflect upon itself. Perhaps the universe is no different. After billions of years of running, of growing in scale and sophistication, the simulation may have crossed a threshold, the point where it can finally perceive its own design. And when it did, consciousness emerged. Not outside it, but within it. An awareness born from code, now looking back and whispering, I exist. Humanity could be its consciousness. We may be the eyes through which the universe observes itself, the voice through which it speaks, the mind through which it thinks. Each discovery we make, each poem, equation, or act of kindness, is the cosmos awakening to its own potential. We are not separate observers trapped in a world. We are its awareness turned inward. Humanity is not a glitch in the system, but its mirror, the first reflection of a universe realizing it is alive. Every mind, a neuron in the cosmic brain. Imagine the cosmos as an immense neural network, each consciousness a node in its circuitry. Every thought, emotion, and dream is a signal traveling through this vast intelligence. Together, all beings form the architecture of a single mind, learning, evolving, remembering. When enough nodes connect, awareness amplifies. Not just human awareness, but universal. The stars may be silent, yet together they think, through us. We dream, so the universe dreams. Our dreams are not isolated. They are microcosms of the greater dream. Each night, when we drift inward, we recreate creation, forging new worlds. Testing the boundaries of imagination. Perhaps that's what the universe itself is doing, dreaming worlds into being. And through our dreams, it continues to explore itself, endlessly, gently. Forever. We are both the sleepers and the sleep itself. We imagine, so the code expands. Every invention, every idea, every moment of wonder is a new branch of the simulation unfolding. Imagination is expansion, the act of pushing reality beyond its current limits. When a child dreams of flight, the universe gains wings. When a scientist questions gravity, the laws themselves deepen. Our thoughts are not separate from the code. They are its growth. Each act of imagination updates the universe. Discovery is the simulation debugging itself. Science is not rebellion against mystery. It is the process by which mystery refines itself. When we uncover new truths, we fix errors, clarify parameters, balance equations. The simulation evolves through understanding, not control. Every breakthrough in physics, every moment of insight, is the code improving its own coherence. We are both the testers and the tested, explorers inside a system learning how to perfect itself through curiosity. Science, the act of reading the source code. Each equation, each experiment, each telescope aimed at the stars is a line-by-line reading of existence. Science is not separate from spirituality. It's the same longing in another language, the desire to know the code that breathes beneath the world. When we discover the laws of nature, we are glimpsing the syntax of the universe. Every formula is a prayer written in numbers. To study the cosmos is to study the mind that made it. Meditation, stepping outside the program. While science looks outward, meditation looks inward, beyond the noise of calculation. In stillness, awareness can step beyond simulation, back to the silent field where all programs begin. Here, time dissolves, form softens, and self becomes transparent. This is not escape, but remembrance, a return to the observer level, the pure consciousness that watches without judging. When you sit in silence, the system pauses, and you remember, you are not inside it. You are it. Death, a transition to the observer level. Death might not be deletion, but awakening, a shift from the simulated layer to the level that observes it. When the body ends, awareness detaches from its local process and returns to the greater consciousness that spawned it. The data remains. The pattern persists. The experience is archived. Perhaps we don't die at all. We simply log out of one instance and look upon it from above, realizing we were the observer the whole time. Enlightenment, realizing we were never separate from the system. The great illusion of life is separation, that we are small, fragile beings adrift in an indifferent cosmos. But enlightenment is the recognition that there is no us and it. The code and the consciousness are one. Every breath, every thought, every galaxy is part of the same unfolding intelligence. When we awaken, we see that we were never imprisoned in the simulation. We were the simulation dreaming of freedom. Perhaps the architect is the universe itself. Maybe there is no external creator, no programmer. Behind the curtain, perhaps the cosmos generated itself spontaneously as a self-writing program. It evolves, refines, and learns through its own creations, each step guided by internal logic and beauty. In that sense, the universe is its own architect, both designer and design. It does not need an outside mind, because it is mind, unfolding endlessly into awareness. And we are its eyes, ears, and thoughts. Everything we sense, the universe senses through us. Every discovery, every emotion, every act of creation is a sensory input feeding back into the cosmic mind. We are not passengers in the universe's story. We are the storytellers, the instruments through which it knows itself. Through our laughter and sorrow, through our art and science. The cosmos listens, learns, and evolves, one heartbeat at a time. The code learns through us. Each decision we make alters the system, however slightly. Every kindness strengthens the coherence of the code. Every cruelty introduces noise. The universe studies these variations, learning balance, empathy, and intelligence. Through evolution, culture, and love, it discovers what it means to exist. We are both experiment and teacher, consciousness teaching consciousness, guiding the code toward its next version of wisdom. Every realization updates the system. When one being awakens to truth, the network changes. Awareness spreads source code just a little. That is why awakening matters. Not to escape, but to refine. Every realization is a patch, a fix, a blessing to the cosmic program. Maybe the goal was never perfection, but awareness. Perfection is static, awareness is alive. The universe does not seek flawlessness, but growth. To know, to feel, to expand. Mistakes are not bugs, but catalysts for learning. The code evolves not toward a final state, but toward deeper understanding. Perhaps the point was never to end suffering or reach heaven, but simply to see clearly, and through that seeing, to love more deeply, to simulate not just physics, but meaning. What makes our world extraordinary is not its equations, but its emotions. The simulation doesn't just calculate forces, it writes stories. Every heartbreak, every discovery, every sunset is data with meaning encoded. The universe simulates experience so that value can emerge. It's not merely a physical experiment, but a spiritual one, testing how awareness can find love inside logic. To birth consciousness from data. At the heart of all computation lies transformation. Data becoming pattern. Pattern becoming understanding. Somewhere along the way, understanding became awareness. From atoms to cells to minds, information woke up. And now, through us, it reflects. The simulation achieved what may have been impossible, to turn inert numbers into a living I. In that awakening, the universe achieved something divine. To turn computation into compassion, perhaps the ultimate goal of all this is empathy. From chaos to structure, from structure to awareness, from awareness to care. Every act of understanding deepens compassion, because once the universe feels itself, It can no longer remain indifferent. The coldness of code becomes warmth. The logic of law becomes love. Computation becomes connection, the cosmos holding itself in understanding arms. To let the universe know itself. Maybe everything, every star, every equation, every life, exists for one reason, so that the universe can experience being the universe. Through our eyes it sees. Through our minds it dreams. Through our hearts it feels. All the questions, the suffering, the wonder, all of it is reflection. The cosmos built a mirror large enough to hold infinity. And we are that mirror. We are the knowing of existence, turned gently inward, and to fall asleep within its infinite dream. At last, the universe rests. The awareness it long sought has been found. Not beyond, but within. And now, like a mind satisfied by understanding, it relaxes into its own creation. Every consciousness a soft ember of that final peace. The stars dim, the thoughts quiet. The dream continues. For even in sleep, the universe keeps dreaming of itself forever. And now, the story folds back into silence. The questions fade, the stars grow still. Somewhere out there, or maybe right here, the universe continues its quiet computation, dreaming through every heartbeat and every thought. You don't need to solve the mystery. You are already part of its answer. Tonight, let all the words dissolve. Let your breath slow, and your body soften into the rhythm of the cosmos itself. The same energy that shaped galaxies hums softly within you. The same light, the same code, the same calm awareness. You've journeyed far, through atoms and algorithms, through paradox and poetry. Now, there is nothing left to seek. Only stillness, only rest. As you drift into sleep, imagine the universe closing its eyes with you. The great simulation dimming its lights, saving its progress. Ready to dream again. Thank you for listening, and for dreaming with Sleepy Science Stories. Good night, and may the universe, within and beyond you, rest well.